Hello, everybody. My name is Jessica. I'm one of the course facilitators for this class. Welcome to the office hour. I'm just going to wait a few more minutes in case some people are late to join, and then we will start with the presentation and the office hour. Okay, great. I guess we can begin. So I'll do the introductions again. My name is Jessica. I'm one of the course facilitators for this course. Welcome to the week 1 office hour. So the way I'm going to conduct this office hour, I have some slides with a summary of the topics that were covered in week 1, such as Python basics, data types, lists, functions, and a little bit of an introduction about the NumPy library. I'm going to show you also some coding examples, and we will review a little bit how to run scripts in Python and what you were supposed to do during week 1 on the DataCamp website. So I will start. Another couple of things that I want to say is if you have any questions during the office hour about the material or some questions about your understanding of the topics covered in this week, I will invite you to use the Q&A button at the bottom of the Zoom window. And I will answer all of your questions at the end of my presentations to keep the flow going. And finally, the recording and the slides of this office hour will be posted on Canvas within 24 hours. So we can begin. So I will start sharing my screen. If you have any issues seeing the slides or hearing me, you can use the chat functions in Zoom, and we will try to fix the problem right away. So welcome to the first office hour for this class. I want to start this office hour by giving you a little bit of an introduction to Python again, just to refresh your knowledge, and in particular how to run scripts in Python. So we can assume that we have our Python script. So let me open a new one here. It would be just 1 second. Okay, so suppose we have this script with some line of code that we want to run. So if I want to run this script from my computer, then what I would need to do is open up a terminal and then navigate to the folder where the script is saved. So I am going to start to navigate to that folder. So in this case is right here, just 1 second. So you see here that after I navigated to the folder where all the scripts are are saved. So you see the path here in yellow on my screen. I can just write ls, and it will list all the files that are saved in this folder. Now, if I want to run the script, now the script is going to print a lot of things, but the first thing that we're looking for is the answer to this print statement. So so the print statement here says just simply hello world. So if I want to run this on my terminal, I would just say Python and then the name of the script that I want to run. So Python oh1.py. And if I press enter, then you see that I have the string hello world printed to screen. And then some other things that we will learn later during this office hour. So I'm gonna interrupt the script and moving on with the slides. One of the first things that you learned in while doing your data camp exercise was, for example, how to print a screen. So I'll just show you that you can print a different statement to using the print function to screen. And in Python 3, the syntax to use the print function is to write simply print and then use parentheses to basically print the variable or the string that you want to print. Now, of course, if you try to print a string, then you would have to define your string using single quotes or double quotes, whereas you can also print, for example, a variable. So here's I have just a screenshot of what I had in my script before. So we can run it again, and I can show you, for example, how to print a variable. So say I define a variable to be 3.145, for example. I can also print this variable directly by saying print a. And if I do this and I run my script again, you see that I have hello world and then 3.145 if which is the result of my print statement of printing my a variable. Another option to print in Python, and I'm not sure you've seen this in during your data camp exercise, is the formatting printing in Python. So this is a little bit of a more of an advanced Python function, but it allows you to print more complicated statements. So F strings are literals that have an F at the beginning and curly braces around that contain the expression that will be replaced during their value. So the syntax is very similar to the one of the previous print statement that I showed you, except that now you have the ability to print to pass variable with inside your print statement. So for example, again, going back to the script that I want to use, so you see here that I have my first name defined and my last name, and then here I have this print statement, which is a formatted print statement. It starts with F, and that's how Python recognizes that that's a formatted print statement. And then in double quotes, I have my name is, and then I pass my first name and my last name within curly brackets. So now if I run this script now in on my terminal, so I can just say Python oh1.py and I press enter, you see that now my name is Jessica Charby gets printed to screen with first name has been replaced by Jessica and second name has been replaced by Charby. Another important thing that you've learned during your data camp exercises are variable and data types in Python. So variables are essentially labels that we assign to which we assign a numerical or a string value. So you can, for example, assign a string, so a series of letter or a sentence or a word to a particular variable. So in this case here, I have the variable name that has Matthew as a value, so a string, and then I have defined the variable bill, which is equal 75, and in this case it's an integer because it doesn't have any decimal, and then I have the variable tip, which is equal to 10.4, and in this case, the type of the variable tip, it's a float because it's defined as a decimal number. You can add and you can perform basic, well, you can perform operations on variable, and we will see this right away. And then if, for example, you have a more complicated piece of code and you forget what type of variable you're working on, well, then you can use the type functions in Python to print the type of function that you have. So I have an example here, just a screenshot of my code. I can print the type of bill, name, and total, and you see that the output here on the in green is integer, string, and float. Another important data type in Python is Boolean. So I can show you quickly how to define Boolean. We have a quick question that I can answer right away. I'm using IDLE for my programming program. Is that okay? Or are we going to be using a specific version from this course? You can use any text editor that you really want, as long as you're comfortable with it. We will be using, of course, also Jupyter Notebook. If you don't know what are Jupyter Notebooks here yet, I invite you to go and watch the recording and the slides of the webinar that was conducted last Wednesday, and there will be an introduction of how to use Jupyter Notebook. And of course, additionally, if you have any further questions, you can also contact support, and me or the other course facilitator will be happy to help you. Okay, so going back to the basic data types in Python, you see here that I have Matthew, I have Bill, I have tips, and the good things about variable is that, of course, at any point in my Python code or in my script, I can change the type of the value assigned to the variable. So, for example, I can just assign 17.67 to tip, and then for example, I can perform operations, and we will see this later. So you can for example, sum tip and bill, and you can also print the types of the variable, and also a string. So for example, say Matthew, your total is, and then print total. As I was saying before, another important data type in Python are Boolean. So Boolean are type of variables that take as values true or false. So you can use those logical statements to produce more complicated line, of course, and you already used Booleans during the NumPy introduction in DataCamp. One fact about Boolean is that, and I'm going to write here this as a comment. So Boolean are variables that take true or false as value, and because of their binary nature, then just as a curiosity sake, to true is assigned the value 1, and to false is assigned the value 0. So for example, if I'm trying to print, try to print true plus false, and I try to run this on my terminal, let's see what happens. So I'm going to run again this script. Of course, it's going to print more things because because we're building the script together. So I run python oh1.py, and I press enter. And so you see here, additionally to what I had before, I print the type of the variable bill, name, and tip. And then I have this printing statement that I am highlighting right now. So I have print name, your total is, and total. And when I print this, I obtain Matthew, your total is 92.67. And then you see that the next thing that gets printed to screen is the value 1. And it is the result of this print true plus false, and the result is 1, because as I was saying you before, in Python, true takes the value 1 and false takes the value 0. In Python, you can obviously perform math operations. So you can, for example, do basic math operations, so basic arithmetic, such as addition, multiplication, subtractions, and division. And well, you can also raise a number to the to a certain power. So you can use you can compute 2 to the power of 8, for example, and as you've learned in the data camp introduction, Python follow the standard order of operations. So unless you use brackets, then divisions and multiplications are computed before addition and subtraction. And if you, of course, if you use brackets, then it will follow the regular order, arithmetic order. So here you see that I have A equals is 45, B is 25.3, and C is 3.1. And you see here that the results are, result 1 and result 2 are different when I print them to screen, because in the first example, C gets divided by B first, and then A gets added, whereas for result 2, A and B gets added for, and then the final result is divided by C. As I was saying before, aside from basic arithmetic operation, you can also raise a number to a certain exponent, and in Python, the symbol in Python to do so is a double asterisk, whereas which differentiates from the multiplication, because for the multiplication you only use a single asterisk. Python also know the symbol less than, greater, and greater than. And an example of how to do this is that if I define A equals 11 and B equals 2, well then I can raise A to the power of, I can raise A to the power of 2, and then ask Python whether A is greater than B. And so I can print that as a string and then print the result. And the result is, it will be true because 121 is obviously greater than 2. So a quick example of how to do this. So just to change things up a little bit, I can say that A is equal to 16 and B is equal to 136. And then I raise our B to the power of 2. And then I can ask Python, is A less than B? And then I can just print now A less than B, and we can see what the result is when I print my when I run my script. So I can do again Python oh1.py, and you see here I have 256, which is my 16 to the power of 2, and then I print the screen is A less than B, and I obtain true. As I was saying, 2 very important types of data types in Python are integers and floats. So I'm just gonna go over it quickly. Integers are a number without the decimal part, so literally like integers, and floats are a number with the decimal part. And the distinction, the main reason for the distinction is that computers stores integers and floats differently, so they occupy a different amount of memory, and you can change a variable type from integer to float and vice versa as follows. So if A is defined as 35, so as an integer, I can change the type, or you can also say cast A to a float, and then for example, going back and redefine A as an integer using float or int. We have a chat. Yes, I can definitely try the, thank you. I'm going to try to change the editor mode to basic. Okay, so I hope this works better. Thank you for the suggestion. I hope this is more clear for you. Going back to the slides, I'm just gonna, way better. Okay, you're welcome. Okay, so another quick data type in Python are strings. So as I was saying, you can define strings by defining some text by single quotes or double quotes. And the reason for you can use both. Python is not going to return an error, but for example, if you're trying to print a quote, so you want to use single quotes to, for example, spell don't, so DON apostrophe T, then I would encourage you to use, then you have to use double quote to define your string. So although both types of quotes are accepted in Python, I encourage you to use double quotes just to avoid mistakes. And as you see here, the slash that I have at the end of some of my strings that I've defined here is just a escape character to make the code more readable if you're defining more strings. Another thing that I want to say, it's a little bit of a different thing that than what you've seen in your DataCamp introduction, is how to get user input. So here, really quickly, you can use the command input to print to screen a question or to assign a type, a value to a certain variable. So I can, for example, ask Python to ask me directly how old are you to screen, and I would insert, I would enter how old I am, and that value gets assigned to a variable. So quick example here from my code. So I can just say, assign age, assign to age the result that I will input to screen that ask me how old I am. And then I can just use a formatted print statement to print how old I am. So let's see what happens if I run this. Whoops. So for example, I can run this script, and you see here that at the bottom line, Python asks me how old are you? So I say 29, and then 29 gets assigned to the variable age, and the string I am 29 years old gets printed. The next topic that you have learned about during your DataCamp, well, our list, and I'm going to go back to list quickly after I finish this, but I want to talk a little bit about functions. So functions are an essential part of the Python programming languages, and during the first part of your DataCamp introduction to Python, you've seen some functions that were built in Python. So for example, your print statement, or the type statement, or the addition, subtraction, or the logical operator that we've learned before. However, as you become a more expert coder and you have to run more complicated type of function, you'll constantly need to write your own to solve a problem that your data poses to you. So for example, if I want to compute a tip on a certain bill, or the average, well, not the average is already defined in Python, but if I want to use more complicated function, then you need to define your own. In short, functions is a type of programming to bundle a set of instruction that you want to use repeatedly. So if you want to, if you know that you will the need to compute the tip on a certain bill multiple times, when it will be way easier to just define a function that does that and call the function when you need it, rather than write the operation that computes the tip on your bill. Functions are self-contained, and you can look at functions are subprograms. And all of this means that function is a piece of code written to carry out a specific task. So, for example, as I was saying with the tip computed on the top of your bill. You've also learned how to define functions. So in Python, functions are defined using the keyword def, and using this keyword, Python will recognize that you're about to define a function, and this is followed up by the function name. Next, you need to add parameters to the function. So they should be written within parentheses, and you're supposed to end your line with a column. After you have defined the name and the parameters that you want to pass to the function, then you will need to add statements that the function should execute, so that set like that bundle of instruction that your function is supposed to do. And then you're supposed to end your function with a return statement if the function should output something. So here I have, I'm going to do this again. I have a very simple example of a function. It computes this the sum of A plus B. It's very simple because obviously Python already knows how to do A plus B, excuse me. Excuse me. And then I returned the result of sum. So here I have def, and then the name of my function, which is plus, and takes two parameters, so A and B. And then I have the colon, and then the bundle of instruction, and then the return statement. So I can show you quickly how to do this in Python. So I just gonna use oops. I want okay, so let's do this quickly, so I can just for example define a function that computes the difference. Say I'm gonna call this difference, and then this function takes the difference of two arguments that I pass to the function. So say A and B, and I use the column, and then I hit tab because Python needs a to format the code. So you can say diff is say A minus B, oops, and then here I can just say return diff, and then if I want to call this function, I can just say diff one say is equal to difference of 10 and 8. So here very simple, and then I want to print diff 1. And then I go back to my terminal and I'm trying to run this script again. So I say Python oh1.py, and okay, I have to like run again, and then you see here that the last statement that gets printed to screen is 2, because it's obviously the difference between 10 and 8. Now, suppose that your function was supposed to do something a little bit more complicated than just computing the difference between two numbers. Well, if I want to compute, if I want to pass different parameters to the function, or I want to use the function to compute the result of different variables, well, then I don't have to run or to define the function from scratch. I can just call the name of the function with different parameters, and this will give me the result in a much quicker way. So you see here, I'm just gonna comment out these lines, some of them. So if I run my code again, you see now that the difference it's 14, and I didn't need to define my new function difference again. Of course, this is a very simple example, but if your function gets really complicated, and that's why functions in Python are so convenient. Another thing we need to be careful is that Function usually, well, function take usually the more simple type of function take a predefined number of arguments. So for example, my functions before was taking only 2 arguments. If I try to use the function different by passing only 1 argument or 0 or more than 2 arguments, well, then I will get an error because the function expects to use 2 arguments, and if I pass too many or too few, then the function will return me an error message. You can also, you've learned though that you can define function passing a variable numbers of arguments. So if you use asterisk quarks, you've seen in your data camp introductions that that is a function that can take a variable number of arguments, but you have to define a function to do so. And you can also write function to have, for example, an optional argument. So here I have the function greet. So the function greet takes name as an argument, and then it has this this message parameter that has a predefined value to it. So it's supposed to say good morning. Next, I added a description of what the function does. So you can use those double quotes to add a description of what your function does. So this function greets the person with a provided message. And if the message is not provided or you pass something different, you want the function won't print good morning, whereas if the message is not provided, then your function will print good morning. So the return statement of this function will just be print hello and then the name plus comma, and then the message that I want to pass. So you see here that if I call just greet where the argument k10 without the message function, well, then here as an output, I obtain allocate good morning because the function uses the message good morning as default. Whereas if I pass a different message, so I want to say Bruce, and then how do you do? You see here that the output would be hello Bruce, how do you do? Another topic that you've covered in your data camp introductions were list, and we will go back to list in a little bit, and then also Python libraries. So Python, as you've learned, when you install Python on your machine, Python comes with some predefined libraries, so functions. So for example, the print statement, as I was telling you before, the type, and raising a number to a certain exponent. Although Python is such a powerful programming language that Python has third-party libraries. So libraries that are designed to perform a certain set of operations. So for example, we have for example, pandas or NumPy or SciPy that were defined by third party. So for example, we have PyPy, which is which has inside of it matplotlib, which is a Python that is designed to produce plots in Python. You can have NumPy. So you've seen a little introduction to NumPy, and NumPy is designed to work with one-dimensional, multi-dimensional arrays in Python. And then in the next weeks, we will also talk about the library pandas, which is one of the most important libraries for data science. So we'll definitely learn a little bit about this. And okay, so now I want to quickly go back to lists and the NumPy function in Python. So to do so, I'm just going to use the DataCamp website. So I hope everybody in this course was able to access this page and complete watch all the videos and complete all the exercise that were required. So just again, a quick review of how to do this. So you can use the module tab on Canvas and then scroll to week 1. And if you click on introductions and instructions, well, then you would have the possibility of clicking on the link Basic Data Camp, and you were redirected to this page. So you were supposed to compute 4 say chapters about the Python introduction. So the first one was about Python basics. So I will I went over on how to run a script and what are Python basic data types. Next, you were you learned a little bit about lists and then functions and packages, and finally about the NumPy library. So here for list, I'm just gonna go over some of the exercises that were defined in DataCamp to do so. So you see here that to create, well, first of all, what are lists? So lists are an important data type in Python. They are defined using square brackets, and lists are data types that are changeable. So once you have defined a list, you can change the number, one of the values or one of the variables that is assigned in a list. The elements in a list are ordered. So the first element has index 0, because remember Python starts counting from 0. And also another thing about lists is that they accept all types of data types. So they accept strings and floats and integers and Boolean. So here I'm just going to open an empty script again, where I'll just show you how to define a list. So I will just comment it out here, some of the print statement that I have used before, or just so here, just quickly, I can just actually delete this because it's quicker. So just quickly as a review about list. So I told you at the beginning that I can define a list by using square brackets. So I can just say my list contains 1, and then to separate the variables I can use a comma, so 23.5, and then it has the string, for example, Jessica. And also if I defined a variable before, so I have temp, I can also pass temp is as an element of the list. So if temp is equal to 23, then I can just pass this. Of course, you can print lists, and as I was saying before, the elements of a list are ordered. So for instance, well, I'm just gonna going to define a few more elements here because it will be convenient when we talk about slicing in list. So I can print the, if I want to print the second element of the list, well, then I would say print list 1 and then 1 as the argument, because remember Python starts counting from 0. So let's see what happens when I run this script. So I'm sorry, I have to navigate again to the code where the script is saved. Okay, so now I can run Python OH1. So you see here that I have my list defined as I wanted. So here actually you see temp was 23, so I have the element 23 in my list. The list gets printed using the print statement, and then the first element of the list gets printed again. One of the next topic that you learned about list is slicing a list. So select a certain range of elements in a list. So if you learned this, you've learned how to do this multiple times, well, multiple ways in your DataCamp introductions. So if I want to select, say, the first 3 elements of the list, well, then I would just say 0 and then column 3. And the reason why I do 0 to 3, which is in Python, you could think that there are 4 elements because you have the element 0, 1, 2, and 3, is that the last element when you're slicing does not get included in Python. So if you want to print the first 3 elements, then you would say 0, column 3. So let's see what happens when I try to run this script now. You see that I obtain 1, 23.5, and Jessica, which are the first 3 elements. You can also slice a list without actually telling it when you want to finish or end your slicing. So you can do this by using just column and without specifying the final index that you want to print. So you can say, for example, 2 column, and this will print all the elements in the list, starting from the second one to the last one. So when I run this, you see that I get the second element, the third, fourth, fifth, until the last element. Another interesting thing that you've learned about slicing in slicing list is that if your list, for example, is really long and you don't know exactly or you don't remember how big is your list, you can start slicing from the last element. So to do this, as an example, you can print list 1, and then if you, for example, say -1, well, because you're using the negative sign, Python will recognize that you are you want to use you want to print the last element of the list. So if I will just comment it out, some of those lines for clarity. So if I run this script now, you see that my list gets printed, and then while the first element, well, actually the second one, because that is as index 1, and then the last one. You can also print, for example, the elements using the negative sign, for example, starting from the second last one. So you would say -2 and then column, and if I run this, you see that the second last element and 2.4 gets printed. As I was saying, another quick things about lists that you've learned in your data camp introductions is that lists are mutable, and by that I mean that you can access a list and change one or multiple values, of the values that are defined in the elements. So, for example, I can do this 2 ways. Of course, the more tedious and long way is just to copy your list and then, for example, paste, and I can change the element here. Although this is obviously not the best way of doing it. If you know that you have to change a specific element in a list, well, then you can just say list. Then you can just access the element of a list and say, for example, list 1 of 2 is equal to Jessica. So this is actually defined as a string. I'm sorry. And so you see now list 1 as student, and now I change the value of the second element to Jessica, and I want to print list 1 again. And when I run this script in my terminal, well, then I get again the original string where the second element has been changed to Jessica because I just changed the value of the second element. You can also delete an element of a list. So this is quickly the last thing that I want to say about list. You can do so by using the del function in Python. So you can say del and then list one, and then say if you want to delete the first element. And then if we print this now, the first element of the list should not be there anymore. So when I run this, let's see what happens. So you see here that my the first element before in my list was 1, and then after I deleted that, the first element becomes 23.5. And of course, you can access any element or slice certain element, multiple elements in a list, and just delete them. Finally, I want to go over, well, you've seen in the slides what functions and packages are in Python. So some of the list methods. So for example, you can compute the mean or the median, or perform some more complicated operations on this. But finally, I want to talk a little bit about the NumPy library in Python. So NumPy is a fundamental Python packages to perform that data science, and it is designed to work on one-dimensional or multi-dimensional arrays. So you've seen how to perform operations on NumPy arrays, and the reason why NumPy arrays are powerful is because especially if you want to define for example, a two-dimensional array, it is very convenient to do so. And additionally, NumPy, the NumPy library comes with a set of functions that are designed to perform numerical operations on arrays. So we have, for example, we learned about basic statistics, so how to compute the standard deviation, the mean or the median on NumPy arrays, and also how to perform operations on NumPy arrays. So quickly, just a reminder of how to define a NumPy array. So for example, so here, just let's go over how to define your NumPy array. So here you see that I have a list, and to tell Python that you want to use the NumPy library, you have to import. So let's see here. So I have my my list here. So let me just change my string to a number, because I'm gonna operate on a NumPy array. So I can tell Python that I want to use the NumPy library and its function by say import NumPy as NP. And the reason why we import NumPy as NP is it's really conventional. So when it is a conventional thing in Python to instead of writing NumPy, to use NP. And you will learn that there is a conventional way for for pandas and other standard libraries in Python. So suppose now that I want to convert list one to a NumPy array, to tell Python that now this becomes an array and it won't be a list anymore. So I can say np list one is going to be np.array. So basically what this means is take from the NumPy library, use the array function that converts a list to an array, and apply this to list one. So if I let's see what happens now if I try to print np list. So here I go back to my terminal, and when I run python oh.1, you see now that I changed the value of Jessica again. So let me just comment that out and run this again. You see here that I have a NumPy array, and the difference on the print statement is that Now all the numbers are converted to float. So you have here the first element as 1 and here as 1 point, and then the 0 is omitted. And also when you print NumPy array, the elements are not separated by a comma, but just by a single space. So you have learned how to perform operations. So if I say I defined a second list, you can just say very, very simple. So list 2 is equal to 1, 2, 3, 4, 5. So let's just say that this has 8 elements, so 6, 7, and 8. Well, I can compute, you've seen on DataCamp, there was an example about the height and weight of some baseball players. I can convert, here I can convert list 2 to a NumPy array, so np dot array, and then list 2. So I can save this and then say print, for example, the sum of list 1, np list 1, and then np list 2. So actually, I think no, that should be okay. If I run this now, you see that the last NumPy array that gets printed here is just the result of the sum of np list 1 and np list 2. Of course, I can perform more complicated operation. I can say raise np list 2 to the power of 2 first. So you've seen here, for example, when you were computing the BMI of the baseball players, and you can obviously divide and or multiply or subtract the one array from the other. So very simple. Here you see that when I do, for example, a subtraction, I obtain also negative numbers and so on. Another thing, while you have learned how NumPy array can be sliced in the same, following the same syntax as list, so you can select a range of elements, or for example, just one element at a time. And of course, as list, NumPy array are changeable. So if you want to change the one or multiple values of a NumPy array, well then you can do so. We have also seen as how to define a 2D NumPy array. So you can look as a 2D NumPy array as, for example, a matrix. So a matrix is just a table that has rows and columns, and you have elements that are defined. So here, for simplicity, I'm just going to copy and paste the baseball matrix, sorry, the two-dimensional array. So I can save this, and then again I can convert this to a NumPy array. So I can say np baseball is np dot array, and then baseball. So when I do so, I obtain and then when I print it, of course, I can you will see at the screen, I would just get my 2D NumPy array. Another quick thing that I want to say is that whether you're converting a one-dimensional or a two-dimensional array in Python, the function stays the same. So you can use just np.array, and Python will know that you're working with a one-dimensional or a two-dimensional array. So if I run this now, you see that the baseball arrays be converted to a NumPy array, and now I can perform operations. If you have a very complicated NP array, you can also print the shape. So you can use the shape function that comes already with the Python library. So you can say np baseball and then dot shape. And if I run this in my terminal, you see that now the dimensions, so the shape of this array are 4 and 2 because it has 4 rows and 2 columns. Quick thing that I want to say: we have about 5 minutes until to the top of the hour. You can also slice 1 or 2 dimensional arrays, as I showed you before. And so let's go back quickly to see what the syntax is to do so. So say you want to select all the element in the first row. Well, then I can just say print and then np baseball, and then you can just say if I want to select all the elements in the first row, I would say 1 comma colon, and then what this is saying is take the first row and then all the elements in the second column, because and print them. So this should be fine. Let's see what happens. I want to comment out some printing statement just to make it clear. Oh, I made a error mistake. Yes, so you see here that when I can just use square brackets to select some elements in your array. So you see here that only the first the elements, well, in the second row, I suppose, if I'm using the index 1, gets printed, so 215 and 102.7. In the same way, you can also select all the elements in the first, say in the first column. So here I'm just going to write second for clarity. So you can do so by say print and then np baseball. And because I want to select all the element in the first column, that I would use the column symbol to select all the rows, and then say use a 0 to tell Python that I want to print all the elements in the first column. So let's run this quick. So you see now that all the elements in the first column of baseball gets printed. And of course, last thing that I want to say is that you can also print a single element. So if you want to print the element with index 0, 1, well, this would be the syntax that you would be using. So when I run this, I obtain the elements in the 0 row and first column. So we have about 2 minutes to the top of the hour. So if you have any questions, I can try to answer them really quickly. Again, I hope that you found this office hour helpful. And as a reminder, as I said at the beginning, the slides, the recording for this office hour will be posted on Canvas within 24 hours. If you have any other questions, you can use the support button on Canvas. And last thing that I want to say is that the material access to the material of week 2 is already accessible on Canvas, so you can also start doing the exercises and watch the video of on the material regarding week 2. Quickly, let's see what the topics that will be covered in week 2 will cover. So you can here go on the course outline, and you see that in week 2 you will you will learn how to use the Matplotlib library, which, as I was saying before, is the library that is designed for plotting. And then we will learn what a new data structure in Python, which are dictionaries. And then we'll learn a little bit about Boolean operation that I was telling you about before. And finally, how to use loops, so the for loops and the while loops. So we're now at the top of the hour. I hope you have a great day, and I hope that you found this helpful.